Hi guys, welcome to another video. Still Caltronics. In today's video we are having a circuit to find a DE relating V1 and V2. So this is the circuit is given. We have the R, that's the resistor, and we have the two capacitor, that's C and C, and you have V1 and then the V2. So you have 3 node, that's this is node 1, and also this is node 3, this is node 2 respectively. So we are going to apply a nodal analysis to find a differential equations. So remember our I, that's current I of t in terms of capacitor. Since we are going to apply a nodal analysis, we are talking with KCL, so we are going to find or enumerate the I for both capacitor and resistor. So you know that I for resistor will be equal to V over R, and I of t for capacitor, you know that is equal to C dV of t dt. So this is the I, verse I for capacitor and volt and the resistors. So this is resistor, that's R2, and this is R1, and here is voltage and voltage. So we are going to apply a nodal analysis to find a given DE. At node 2 we are going to apply same procedure. We can say C dV from here, this is where V applying at node 2. We can say V2 minus V3, that's C dV2 in parenthesis V2 minus V3 dt, then plus V2 minus V1 minus V1 over the resistor R2 is equal to 0. You can call this equation 2. At node 3 we are going to say we have a V3 over R1, that is I, plus C dV3 minus V1 by dt, plus C d into parenthesis V3 minus V2 all over dt. Say this is equation 3. From equation number 3, since we are going to find the relationship between v1 and v2. So we are going to evaluate a v3. This v3, we are going to evaluate it in terms of v1 and v2. So by making a v3 here to be subject, we can multiply both sides by r1 and equalize the equations. So we are going to say a v3 must be equal to minus cd into v3 minus v1 dt, then times r1 minus r1 cd into v3 minus v2 dt. So from here we are going to open a parenthesis. We are going to say v3 is equal to minus r1 c dv3 dt plus r1, this one times this one will be plus r1 c dv1 dt. If we open this parenthesis, we will have minus r1 c dv3 dt plus r1 minus times minus plus r1 c dv2 dt. So from here we are going to say, we are going to add this one and this one since they are equal with v3. So we are going to say v3 is equal to minus 2 r1 c dv3 dt plus r1 c dv1 dt plus r1 c dv2 dt. So we will call this one, we can call it as equation 4. So this is a v3. We have get a v3. So so we can go back to equation 1. From equation 1 we know that we have c d v1 minus v3 dt plus v1 minus v2 over r2 is equal to 0. From equation 1 we are having this one as equation 1. So by opening a parenthesis we are having c dv1 minus c dv3 dt plus v1 minus v2 over what? r2. So from here we can make this one to v, since it is equal to 0, we can take this with v3 in the right hand side. We will say dc dv3 dt will be equal to c dv1 dt minus, if we shift it to the other side it will become plus as well. It will be plus, since this one is shifted to the right it will be plus this one, that's v1 minus v2 over r2. From here we can divide it both sides by c. We can say over c over c over c. Here goes and this one goes. We will have dv3 over dt is equal to dv1 over dt plus b1 minus v2 all over c r2. We can call this equation 5. Since we have a v3 over dt, we can substitute it in equations 5. Therefore, we can say substitute equations 5 in equation 4. So we can go back to equation 4, where we have a v3 here. We have a v3 as this, and from here we have this, the v3 dt. So we are going to put equation 5 at equation 4 in order to remove the v3 dt. So here we go. So we are going to have a v3 is equal to minus 2 r1c in parentheses, that's the v3 over dt. Since we substitute, we put this, so we are going to have the v1 dt plus b1 minus v2 all over r2c, then plus r1c dv2 dt plus r1c dv1 dt. Then from here we can make some arrangement. We can open a parenthesis. We can have minus 2 r1c dv1 dt minus 2 r1c v1 minus v2 over r2c plus r1c dv2 dt plus r1c dv1 over dt. So from here we can say this c goes with c, and then from here we are having minus 2 r1, we are having minus 2 r1, but since here this r1, this one is in terms of v1 and this one in terms of v1, we can add them together and they have equal r1 and c. Then we can say minus 2 r1c dv1 dt plus r1c dv1 dt will be positive r1c dv1 dt. Then here we have a minus 2 r1 r2, c goes with c into v1 minus v2, then plus this one. Since this one goes with this one, remain one only. Then we can say we have this plus r1c dv2 dt. This one we are adding this one and this one together, thus they give us this. So we are going to say this is an equations. Here is v3, this is equation number 6. Since here is we have evaluated the v3 in terms of v1 and then a v2, we have nothing v3, so this v we are going to look back as the equations to find which equation we are going to put to evaluate to get the relationship between v1 and v2. So if you look equations note 2, that is equation 2, we will have c dv2 v3 minus v3 dt plus v2 minus v1 over r2. So since already we use with equation 1, so we are not going to take it again, and we make a v3 subject of the formula in node 3. So we are going to take a questions 2 to evaluate the relationship between v1 and v2. So since here is c dv2, we can open a parenthesis. By opening a parenthesis, we will have something like this, that's c dv2 over dt plus c d minus c dv3 over dt. So the only problem is that here we are still having a v3, and we want to find the relationship between, we want to find the only relationship between a v1 and v2. So by going down to our equations, we have the equations this. We have the equation 5, that we have a v3. So we can take v3, this equation 6, to put it in equation 2, or you can differentiate this to become d3 over dv3 over dt. So from equation 2, we can say from equation 2, so normally you can take this value of v3 and put it to equation 2, but you have the v3 at the t, so you can differentiate this v3 with respect to t and put it there, so no need to open a parenthesis. So simple means we can differentiate this v3, we can say add differential to both sides. So we can say dv3 over dt. We can add differential throughout. We can say r1 c, since here is first derivative and we add derivative through each element, this one becomes second derivative, d square v1 over dt minus 2 into r1 over r2. Since there is no derivative here, then it will become a first derivative, that's d v1 minus v2 plus, and therefore here also it is first derivative. By adding a derivative throughout, it will be second derivative, that's r1 c dv d square v2 over dt, but all in squared. Here is first derivative, sorry, there is no square. Here is first derivative, and here is first derivative, here is t square. Okay, so we can call this equation number 7. Okay, so from equation number 2, when we open a parenthesis, we will have r2 c dv2 over dt. When we go equation 2 and open a parenthesis, that's bracket, we will have minus r2 c dv3 over dt plus v2 minus v1, that's equation 8. That's from equation 2. From these equations, from equation number 2, when we open a parenthesis, you will get this. Okay, so this is equation number 8. So since we have a dv, here we have a v2, here we have a v2 and v1. The only problem here we have a v3. So since here, from here, if you like, from this v3, since this is the equation 2, after you rearrange the equation 2, so since here is v3, if you like, from here you can take this, you can put this v as how it is, no need to differentiate. But if you want to replace dv3 dt, you need to differentiate from this. So the choice is yours. If you like, you can put v from here, that's here. If you like, you can put dv3 dt. So since we have a dv3 dt, we can just put this. Therefore you can say r2 c dv2 dt minus r2 c into, in parentheses we will have all this, that's we have r1 c d square v1 dt square minus 2 into r1 over r2 d into v1 minus v2 plus r1 c d square v2 over dt square, then plus v2 minus v1. Then if you look this carefully, we have is equal to 0, we have nothing v3, we have r2, this is v2, this is v1, this is v1 and v2, this is v2 also, and this is v2 v1. So we haven't anything containing a v3. So by opening a parenthesis and clearing a parenthesis and rearrange the equation, we will have a differential equations. Because we don't have much time, we can do it by yourself, but let's open a parenthesis, but the arrangement you can do it to yourself. We can have r2 c d v3 dt dv2, that's v2 dv2 minus this one times this one, it become r2 c r1, this one times this one, into that's c square d square v1 over dt square, this one times this one will be plus, that's 2 r1 r2 c over r2 d into v1 minus v2, here r2 goes with r2, then plus r1 r2 c square d square v2 over dt square, then plus v2 minus b1 is equal to 0. Then from here we have r2 c dv2 dt minus r1 r2 c square d square b1 over dt square plus 2 r1 c d into v1 minus v2 plus r1 r2 c square d square v2 over t square plus v2 minus v1 equal to 0. So this is the differential equation. If you like, you can open this parenthesis but you can leave it at this. This is the final solution. So don't forget to subscribe, give a like and comment. If you have comment, you can comment on the comment sections. Thank you for watching.